or good evening, depending on where you're joining us from. This is a webinar from Nautel for the NX series of high-power AM, medium wave, and long wave transmitters. I'm Chuck Kelly, and I'm joined today by Wendell Lonergan, Head of Sales and long-term employee of Nautel. You started, what, designing the original AmpFETs or something like that, right?
Back in the early 80s, that's right.
A lot closer to your mouth, I think, will be better.
Hey, there we go.
Okay, so this webinar is kind of unique in the sense that it is an introduction, but we're going to kind of fly through that because it's also an update, and that's a very interesting point. This transmitter's got a few years on it already. It's been designed a few years ago, but we've never stopped improving it, never stopped adding things to it. And in most cases, when we've added things, it's available to the existing customers that have had the units for several years. So we'll get into all of that. So we're going to go through an overview. We're going to talk about the NX series in digital, whether it's HD radio or DRM. We're going to talk about efficiency, because that's a really key point these days with the cost of electricity. We're going to talk about control, and that will go right into firmware release 4, a quick summary of that. We're going to take a live tour of an NX50, which is operating down in our test lab, and we're going to get onto the AUI and then let you take a look at that. We're going to investigate and take a look at the NX Combiner system, which allows multiple transmitters to be summed together for higher power. We're going to talk a little bit about long wave, talk about how we integrate systems, mention Nautel support, and then we're going to take your questions, and that's a very key point. So on the GoToWebinar client, you've got the ability to type in questions, and feel free to ask questions at any time during the broadcast, and we will then answer those questions at the end of the broadcast. So we'll be very pleased to have your questions brought up to us. So do write questions to us, and we will do our very best to answer them as time goes by. So here we are. The Nautel transmitters, all of the current models are based around the AUI, the Advanced User Interface, which is a web server which is integrated into our transmitters. From the least of the transmitters, the 300-watt VS series FM transmitters, through the higher power NV and NV Lite series, to the NX series, which we're talking about today, that goes all the way up to 2 megawatts. And even through our new television transmitter series, the NT series. So they're all based on the AUI, and we're going to spend a bit of time walking through the AUI and making sure everybody's clear about all the new features that are part of the AUI. The NX series is a very innovative series of transmitters. It features the industry's top efficiency at 90%. Boy, is that an important thing, Wendell, these days.
Absolutely. The rising cost of electricity everywhere, it's fantastic savings for all the operators.
And the transmitters are also featuring adaptive pre-correction, which is critical if you want to have your transmitter capable of doing digital performance in the future. And this is something we've spent a lot of time working on, these algorithms for adaptive pre-correction. The transmitter includes a lot of interesting test equipment right in the AUI, including RF and audio spectrum analyzers, and as well a network analyzer that allows you to see the status of your transmission system, the antenna system, the performance on a Smith chart of your entire feed line and matching system and antenna. It features very high sampling rate digital modulation. This makes it possible to have a very broad modulator bandwidth, which in turn makes it possible for you to handle the highest power or highest bandwidth digital data systems. It features an intuitive touchscreen interface. It's ultra compact, and it does support all DRM modes plus all HD radio modes. So this is the basic building block. This is a 100 kilowatt transmitter. It's ultra compact. Interestingly, the NX25, 25 kilowatt transmitter, the 50, and the 100 are all housed in the same cabinet. The only difference is that in the 100 and higher power, they have an external transformer cabinet, which is mounted adjacent to or remotely. But basically, in the size of a refrigerator, you have a transmitter that can do 100 kilowatts very, very well. And I can remember the very first station I worked at that was an AM. It was a big room. It was a BC5E Gates transmitter in a big room, and it was 5 kilowatts, and that's all it was. But it was rack after rack after rack of relays and tubes, and to look at one of these things and see how small they've really become and how efficient they've become. Probably that old 5 kilowatt transmitter I had actually dissipated more heat than an NX100 would today.
Oh, I bet it did. And it's amazing how 100 kilowatt transmitters have become routine for us.
Mm-hmm.
They're as routine as a 10 kilowatt transmitter was to us in the 90s.
Yep, that's right. So here's the block diagram of one of these transmitters. They're comprised of 40 modules. This is a 100 kilowatt. 40 modules, each of 2.5 kilowatts. They're all hot pluggable. And then there's a series combiner. And then there's a dual T matching network. And the rest of it is all drive. You have the modulator driver boards. You have the supervision and control board, and two dual DSP exciters that are automatic main standby exciters, fully digital. We'll show you those. And then there's a bunch of power supplies. One of the things to note is that all the low power supplies are all completely redundant. So you could have the failure of a low power supply and stay on the air. And again, the transmitter features dynamic pre-correction. It's the first high-power AM transmitters to be provided with dynamic pre-correction, and there's a number of different algorithms that are constantly or can monitor the transmitter, not necessarily constantly, but can monitor the transmitter and provide information about the performance to the modulator and improve it. And make improvements to that modulator. And one of the things that's really cool when you have this adaptive pre-correction is that you can actually get rid of some of the long-term effects that we've all wrestled with in the past. If you've had a PDM transmitter, the words PDM nipple mean something to you, and that talks about a particularly ornery type of distortion as you get close to 100% negative modulation. And as you can see in this photograph, there is no visible distortion at all in the trough in AM because of the AM to AM correction, which is built into the adaptive. It's a pretty big deal.
Well, that's correct. The analog has gained so much improvements from the technologies that we've innovated in the digital world.
And this is really something you can hear. And up here are all the audio inputs to the left and right, and I and Q inputs, and AES EBU. All of that is built right into that exciter control, or that controller board up here. And then the exciter boards plug into the bottom down here. So let me show you the modulator module. The module of this transmitter has 4 200 ampere FETs in a conventional H-bridge configuration, and you have driver transformers. And this section over here is the modulator, and this section over here is the RF amplifier. One interesting point is that those FETs are 200 ampere FETs, and they're removable with just a screwdriver. You don't need to solder anything if you have to change one of the output RF FETs. And that the module is actually 98% PA efficient and has a 12 kilowatt continuous power rating, and we operated at 2.5 kilowatts. You can see the headroom that's built into the design.
Yeah, it's an ultra reliable design that we have, and very easy to maintain.
This is the schematic. So we were talking about the modulator side and the RF amplifier side. So this is the three phases of modulator. There's actually 6 phases of modulation in the transmitter, which improves the performance of the transmitter significantly. And then here's the H-bridge of transistors that we were talking about in the output stage. This is the module from the side. One interesting thing about this, and it's become true of more and more of our products, there is no adjustments in the transmitter per se. There's no potentiometers, there's no variable capacitors, there's no variable inductors. The transmitter, the entire NX series transmitter, is broadbanded with the exception of the output coupling network, which of course must be tuned to the frequency.
It's amazing. We have no pots in the whole transmitter, and yet we have more control of every feature than any other transmitter before.
And that's because of the AUI.
Absolutely.
Let's look at the combiner here. So the combiner, you're not actually seeing the actual combiner. Inside these metal boxes is a copper water pipe with ferrite cores which couple the RF output across that water pipe. And it can handle many times the required power. It is broadbanded, and the only moving part, apart from the fans in the transmitter, is this relay right here, which is to isolate the transmitter so that the output modules can be hot swappable. This is the output network, part of it. This is where the capacitors are configured up, and internally here you can see the large coils with taps on it. One cool thing about this transmitter is, assuming that you have all the correct capacitors, you can change the transmitter's frequency from one frequency to the other in just a couple of hours, which is a pretty cool thing. This is the schematic of the output stage, so you can see this line right here is essentially that copper pipe. And these are all the modules that couple onto that line with large toroids. So now you've got an output filter here and a matching network. One of the things that's interesting to do, though, when you see a circuit like this, is to analyze it from the perspective of lightning. If you are a lightning bolt coming in the output connector of the transmitter and heading back upstream and wanting to destroy amplifiers, then what happens is we get you many times. The very first thing that happens is that we have an adjustable carbon ball gap. Carbon ball gaps can absorb lots of power, but they're relatively slow to act. So we put them right next to the antenna. Then we have a series resonant high-pass section. So this high-pass section is below the bottom of the AM band in terms of its cutoff point, but above the natural resonant frequency of lightning, which is in the 100 kilohertz range. And so it becomes an impedance to lightning, but passes AM frequencies just fine. And the same thing is true with this harmonic filter here. It also tends to minimize and add time. If you look at these two inductors here, they are seen by lightning as not only an impediment, but also they add time. And then we have a very fast pressurized tritium spark gap here, which is capable of less joules of energy dissipation than the carbon ball gap, but is much, much faster. So we isolate that through here, and we isolate it with time. And then at the end of the day, if you're the lightning bolt and you've made it this far, well, you've got a copper water pipe to ground.
That's right, and it's also worth noting that that series high-pass section, or the series output section, is fairly low Q. So under normal operating conditions, you do not get a very high voltage pulse through shorts on the line or impedance changes.
Yep. So let's see what those devices look like. That's the carbon ball gap that we were talking about. Here's a static discharge choke. This is the tritium, high-speed tritium fast spark gap. So there's also transient attenuator capacitors on the ACs, on the AC secondary coming from the power transformer, and then there's AC surges are also corrected by the phase control B+ rectifiers and differential mode. This is a big chunk of iron, which this happens to be the 50 kilowatt version, but in higher powered transmitters there's a bigger hunk of iron in there as well. So the very first thing that all of the ACs, or all of the transmitter sees is the transformer. So all voltages within the transmitter come off the secondary of that transformer. From a cooling standpoint, there's some simple small drawers. You might be kind of surprised to think of just 5 of these trays in a transmitter that's 100 kilowatts supplying the power to cool a 100 kilowatt transmitter, but it's because it's so efficient. Only 10 kilowatts of heat is generated in a 100 kilowatt transmitter. Typical fan life on these ball bearing fans, not sleeve bearing fans, ball bearing fans, is over 11 years. And then there's the power supplies. So you've got the 3 phases of AC power coming through the transformer, fed to the transmitter, going through a 3-phase rectifier bank, and then there's 10 large fuses which protect the banks of 4 modules. And then we have dual choke input filters, and all of the low voltage supplies are completely redundant. So let's show you some of those. Those are the fuses that break up the B plus going to the modules. And there's the capacitor bank. And there's the low power, or some of the low power supplies, which are redundant. So the transmitter, if you can disconnect the AC from one of those, and transmitter goes happily on, except that the AUI is going to send you an email. One of the things about the Nautel NX series is that we've taken digital radio leadership, and it doesn't make any difference whether you're a fan of DRM or HD radio. They're both OFDM systems, and they're both systems that operate within the AM band, and we support them both. From a leadership standpoint, we're always doing new development to advance those limits. Recently, we've done a lot of work with PAPR and linearization algorithms that will provide more RMS power in fully digital mode from a given power transmitter with better MER, or better accuracy, better digital signal-to-noise ratio. And there's a paper that's coming up this year at the NAB 2014 in Las Vegas, authored by one of our research engineers, Mr. Brian Walker, that describes the algorithms that he's now using to further improve the performance of the transmitters with fully digital systems. That's both the HD digital in full digital mode and some of the advanced systems in DRM that are even, for instance, 20 kilohertz wide, which is very challenging for a transmitter. 20 kilohertz wide DRM, and of course totally digital. We're one of the few transmitters, as far as I know, that feeds the transmitter with true digital IMQ signals transported over AES EBU, and all modes and all bandwidths are supported. So when you invest in a Nautel NX series transmitter, you're getting something that's going to be able to handle the digital systems of today and tomorrow. There's a couple of proof of the pudding type shots. This is a 100 kilowatt transmitter, where we're showing in this shot over here an analog signal with an adjacent DRM signal, and over here we've got a 20 kilohertz wide DRM signal. Now, being good, solid, conservative engineers, we shouldn't hesitate to mention that it requires a pretty reasonable quality antenna system to make this happen. And there's very little we can do to fix the antenna system in the transmitter, although we try.
Although we can look at it from the AUI.
Absolutely. You can see exactly how good or not so good it is. So, and this is pretty interesting too. This is a transmitter, an NX series transmitter, which was utilized for tests of all HD radio. That is no analog signal, not a hybrid installation, but all HD. And here we're doing 50 kilowatts. And notice the amount of room under the mask here. There's a lot of room under the mask. So we're clearing this mask with a lot of headroom. And the Nautel NX series is the world leader in high-efficiency AM transmission. The NX 100 and higher transmitters are 90% efficient, and the 50 kilowatt and below are 88% efficient. And in addition to that, on top of that, we include as standard modulation-dependent carrier-level algorithms within the transmitter. You can select up to 5 of them, and that can provide, has been shown to provide in a number of industry tests, up to an additional 30% savings in electrical costs, above and beyond having a transmitter that's 90% efficient. And the tests that have been done have shown that there's no discernible coverage or performance reduction. And because of these reduced electrical costs, the purchase price of an NX transmitter can often be paid off in just a few years when compared to an older tube, plate modulated, and or solid state design. And that's return on investment. That's the language you got to speak if you want to sell the management on getting a new transmitter. So the NX series is the greenest transmitter out there. Other companies will charge you for the MDCL algorithms, and we made it standard as a part of the transmitter. Now we're going to talk about some of the software improvements in this transmitter. There's an awful lot of firmware, there's an awful lot of software in this transmitter, and we have a policy here of Nautel of continuous improvement. Not only have we never discontinued support of a product that we've manufactured in our 45 years, but we've also never stopped continuing to advance the state of the art, even for transmitters that are not in current production, for instance. So even though transmitters, NX transmitters, have been for sale for a number of years now, we are continuing to add features which are retroactively updatable into people's transmitters, and that includes all of these features here. A lot more features than people thought they were getting when they bought the transmitter, and they got more because it's a Nautel.
Absolutely. That's where the early adopters have got the money back for investing in us early.
And we're going to walk through some of those features in a second, but one that I want to pay attention to here specifically is the MER instrumentation, the ability to take a look at individual carriers in an HD radio transmitter and determine the MER of those carriers to see whether, if those carriers are closer to the analog signal, whether it's affecting the MER or something like that. So it's a lot of good information that we should have. So now we're going to switch. I'm going to try this and see if it works. It's always a bit of a leap of faith. And we're going to go to this browser over here, and we're going to go to full screen, if I can remember how to do that here in Chrome. Yeah, I can. And I'm going to show you, and hopefully everybody's able to see this, show you the AUI of this 50 kilowatt downstairs. So right now what I'm going to do is going to turn it on, and hopefully the transmitter is going to start coming up to power. Yep. Now, the basics of the screen look very much the same as they did before in previous versions years ago. This one's operating in analog at 50 kilowatts. We have the audio input levels. Right now our audio input is coming from actually a USB memory stick. We have some MP3 files on a USB memory stick, and we're playing them out automatically in the playlist of the system, which is a new feature. Right here is the Smith chart, and I can actually take that to full screen and then zoom in on it to try to see something. You can see the little red image. That's our dummy load, and you wouldn't expect it to be very big because it is a dummy load. It is broadbanded. If you had a real antenna there with some real reactance and impedance changes over frequency, you'd see much more there. But right now it's looking pretty good. It's a nice tight situation. So let's look at some of the meters here that are available. You can see the spectrum analyzer that we've got here. You can see the frequency response of the EQ. We can see the impulse response, the EQ filter delay, AM to AM correction, AM to PM correction. These things are all part of the pre-correction, equalization, I guess, that we use in the transmitter. We also have the signal constellation view, where we can actually bring this up, and this is the screen where you would see, if I was running in HD radio mode, you would see the MER in the constellation there. And let's see here, what else have we got? Let's close that and go back to here, and we can take a look at an audio listen view. I'm not sure, yeah, it does work. So it's working using the USB, and you can see we're driving the transmitter with stereo. Small point, useful to know, the transmitter includes CQAM AM stereo. For those of you who are big fans of CQAM AM stereo, it handles it, it's built in. You just enable it, just turn it on. Finding a receiver may be more of a challenge. Modulation levels, audio inputs, and a power distribution graph. So that's what's on those things. Now, what's really interesting when you look at one of these transmitters is to talk about the presets. So let's go to the presets and see what is built into a preset. Now, for those of you who are uninitiated into the way Nautel builds transmitters, a preset is a bunch of settings which pretty much define the transmitter and allow you to make changes in a set of settings in the preset. So we could change the power output, the type of modulation, where it could be analog AM, DRM, DRM plus AM, IBOC plus AM. You can set all those things up. You can set up various configurations. We can come over here, and right now the audio feed for the AM is coming from the audio player, and this is the playlist that we're running. And we've set up an audio level, and it's mono left plus right, and there's no filters involved, but if we wanted to, we could enable one. And if we wanted to have NRSC1 pre-emphasis, we could do that. If we wanted DCC, which is also known as MDCL, which we just talked about, we could just enable it here, any of these systems. And we have over here, AMSS. And that can be enabled or disabled as well. Over here under digital, let's see what shows up under here. I guess there's not much. And then under loss, this is an interesting point, and this is now possible in the NX series. It's been possible in the other FM transmitters for a while, but now we have the capability of saying we've got multiple, if our STL should fail, we want to switch over to a different preset, and it will ask which preset, and we can choose a different preset. And it could be, you know, we bring in a left and right analog, or it could be that we bring in a stream because we can take, you know, a shoutcast or icecast stream and put that on the air. Or it could be that we'll take the USB playlist and put it on the air, and then we can define the number of minutes and seconds and threshold that means that we have an audio loss timeout. You can once you've got all of these things stored, you can have literally 60 or 70, I guess, presets configured in the transmitter. So the preset is a very, very powerful function in the transmitter. Let's look at system settings just a little bit. You can upgrade the software, calibrate the exciter clock, calibrate the RF monitor level. You can set up power lockouts so that you don't have more than a certain amount of power going to a particular antenna. You can set up various power thresholds here as well. So low power and low forward power, and these are things that will cause alarms and whatnot. We can come over here again, and we go to the menu, and then we can talk about pre-correction settings. There, you may wonder about security. You can have multiple levels of security of this thing. You can have an administrator, you can have a read-write access where you can turn things on and off, or you can have read-only access, and each of those are password defined. And the difference between an administrator and read-write is an administrator can actually create new users. So that's very powerful as well. So the security is taken care of. And then we can come down here to changeovers. If we're going to have for the main and alternate exciter, auto changeover, standby exciter, yes, no. So there's all that functionality is built in. And you come down here to user settings. And this is where I think the rubber hits the road. I think if you're comparing various different AM transmitters out there, and you go looking for where you set up the email within the transmitter, you probably won't find many other transmitters that support email configuration. But this transmitter is a fully networked transmitter. This is where you configure up the IP address. Here's where you would configure up the email configuration. Do note a new feature. We now have the capability to work with an authenticated server for SMTP. This is where you configure up the notifications so that if the antenna visual goes high, you send an email to this guy. If the AC mains starts getting low, you send an email to this guy. You can do all of that, or person, shall we say. XGen, just in case you're using HD. SNMP configuration, which now support traps, and so all that's built right in, which was a request by our customers. Critical parameters, time setup. Since we now have a scheduler for this transmitter so that you can configure that when the transmitter goes to high power or low power, it is very important that time be accurate, so we set up the time here, and we set up with NTP here so that the transmitter keeps itself up to date. And over here I can even specify a call sign and ID that will show up at the top of the page and allow the customer to, if they have multiple transmitters, know which one they're looking at. That was also requested by a lot of our customers and is a recent addition. Over here we have remote I/O, so all the remote control within the transmitter. Not only do you have the control of the transmitter through the AUI from any place to see exactly what we're doing here, but you can also, we have also parallel remote control, the more traditional remote control, and you can actually define what each of the inputs and outputs do in the transmitter, what action they will have and how they'll appear in the AUI. So that's very versatile. Here's the scheduler we talked about. The scheduler allows us to take and create a schedule. So you can see here it is a rule-based scheduler. So between this date and that date on this day of the week, we want to do this between this hour and that many times. And we want to, in this particular case, we want to bring in this particular preset. You can imagine this could be set up to set up your high and low power transitions in the transmitter according to your station license. It could configure, for instance, if you had a satellite dish at the transmitter site and you wanted to switch over to using a satellite audio feed in particular time periods, you could do that through because what you're doing is activating the various presets. All the things that are embedded in the preset can be taken care of with this. So it's a very, very powerful scheduler, which is controlled by NTP, so it's very, very accurate.
So you could actually choose a different audio source to have different processing.
Absolutely.
Nighttime as opposed to daytime.
Absolutely. And then there's the playlist editor. So here, this is the USB stick. This is the only file on this USB stick. I suspect if the guys in the training room have a radio out, it's getting a little bit boring at this point because this song's repeating over and over and over. There's also a stream up here, so we could actually play a stream off the internet, which is a Icecast or Shoutcast stream that the guys say is a smooth jazz format. So that's all that functionality is built in here. You can pick up a stream off the internet, put it right on the air. And let's see here. We haven't talked about logs. So there's a complete set of logs here where we can see everything that's going on inside the transmitter. One particularly nice feature is I can come over here and hit copy logs. And now this, of course, I'm using my PC here. I'm in a completely different physical location, only connected up by the internet to this transmitter. On my PC, if I now open up Excel, for instance, and hit Control-V or paste, all of that log that we just looked at will be pasted properly into that Excel spreadsheet, and then I can do whatever I want to with it and mail it over around or whatever I have to do. So that's all built into the transmitter as standard. Now let's do one more thing. I want to show you these meters. First off, one of the things that's cool, it's also a response to customer requirement or request, is that we now have meters which are persistent. So when I log into the meters here, there's a page that pops up, and I can save the configuration of the meters to anything I want, and then the next time I log in with my login, it automatically brings up that list of meters. So that's a time savings for a lot of people. One thing that I want to show you, though, is to go in here, and I want to come over here to this and show you the number of things that we're monitoring in this transmitter at this point in time. So this is a live display of each of the power modules. Each column is a power module. In this 50 kilowatt transmitter, there's 2 pages of them, so there's 20 modules. And it's loading all this information up, and you can see the address, the DC current level, the B+ voltage, the PDM duty cycle, the PA voltage, low voltage supply, RF duty cycle, temperature, fan 1 speed and fan 2 speed. There's tachometer on every single fan in this transmitter. So the amount of detail of information that you can get, it's absolutely true that the AUI is not simply a remote control system. It's actually a embedded, intelligent controller.
Yeah, at a glance, you can see that the temperatures and fan speeds are all the same, so you can very quickly tell that this is a very healthy transmitter.
Which brings up an interesting point. In another type of competing transmitter, the modules work substantially differently in normal operation. In other words, there's a most significant bit and a least significant bit. And the least significant bit is cool, while the most significant bit is flaming hot. So in this transmitter, we share the pain across all the modules, and they're all actually operating very cool. As you can see here by the temperature, I'm not just speaking out of my head, but you can see they're all operating very cool across here.
Absolutely.
Okay, so that's a basic demonstration of the functionality. Did I forget anything here?
I've been working on these for a long time, and I'm still in awe every time.
I know, there's an awful lot going on here. I got to tell you the story, just anecdotally here real quick, about the fellow who walked up to me once at a trade show, and I showed him this Smith chart. There's a little guy from Hong Kong, and he probably was 60 years old, and I was showing him this on a live transmitter, and he actually started to cry. There were tears coming out of his eyes as he said, "You know how many evenings I could have spent with my wife? I was born too early." Anyway, long story. So let's go back, if I can here, and come back to our presentation. here, and I have to go to here, and then what am I doing wrong? Oh, there it is. Okay. I'm going to come over to here, and I'm going to go back to my PowerPoint and show you just a few more things, and then we will get to your questions. I hope you're all coming up with questions here. So, key thing about the NX series, it's completely scalable. The building block size before a combiner can be as much as 400 kilowatts. So you can have 4 of these 100 kilowatt transmitters strapped together, where the copper water pipe goes all the way across and all the way back. So you've got a 400 kilowatt building block, and you can build a 2 megawatt transmitter as simply as a 5-port combiner and 5 sets of 400 kilowatts.
Yeah, it's amazing. I've been in some of these very high power sites in the last couple of years, and our 400 kilowatt transmitter fits in basically one rack of the the previous transmitters that were broadcasting there.
It's interesting also that a number of customers are not taking out the previous generation transmitter simply because the new transmitter that's going to replace it fits in a corner and they don't need the space.
That's exactly right.
So one of the things that makes all this possible is the combiner, and we've developed a new combiner called the NXC. We have 2 models, the NXC 800 and the NXC 200, and it has on its AUI, because it has its own AUI, it has a block diagram of what's going on with green lines depicting where the RF is going through and what connections are being made and what's connected to the test load and what's connected to the antenna, and it's all touchscreen and it's all very easy to use. And over here, this is a screen showing a similar kind of information as we did before about all the modules, but in this case it's showing some of the fan speeds, ambient temperatures, supply voltages, those sorts of things going on. We also have presets, so you can have a DCC mode or no DCC mode. It becomes the master controller for both of the transmitters that are involved. It has its own email configuration. Can you imagine a combiner that actually will send you an email? It has its own audio loss shutdown. So if the audio goes away and you haven't got a backup audio set up, it can actually take the transmitter off for you. These are some of the types of installations. One of the things that's fascinating is that a lot of support stuff, whether it's air handling units or dummy loads or things like that, are far larger than the little diminutive, in this case, 300 kilowatt transmitter that are sitting there. So that the support side of it, as I said, air handling or RF matching or dummy loads and things like that can actually be much larger than the transmitter itself. This is a combined installation. Right here in the middle is the NXC 800 in this case, and I think we may see something very much like that in one of the pictures that are coming up here.
I believe so.
And we build our own dummy loads for these transmitters as well. They're suitable for indoor or outdoor use, and they're fully sealed and slanted, and they don't send any emails, I'm afraid. We also do a lot of integration. This was an installation where we put a 100 kilowatt transmitter into a mobile vehicle, which was run around England, I believe, and was replacing transmitters that were getting upgraded as time went by. So it was a mobile upgradable transmitter.
Right, that thing's been in use. They've had to take out asbestos in many of their sites in the UK, and this transmitter in the container was, nearly 100% duty cycle used.
We also have in our support system, we have offices in Quincy, Bangor, and Halifax. So we are able to make shipments for parts ordered as late as 7:30 in the evening Eastern Standard Time and have them dispatched from our Memphis Quick Ship Depot, which is adjacent to the FedEx facilities. We have 24/7 support, live chat, and commitment. I think if you ask any Nautel customer, you'll find that Nautel series is better supported than most any other product on the market. Just a note to mention, not probably too many people listening today are interested in this, but NX series is also compatible with the long wave band, and it has basically the same features and functions, but it operates in the 129 kilohertz to 283.5 kilohertz band. Otherwise, They're identical functions and features and pretty much performance to the medium wave models. So just a little quick update, I guess, of places we've put transmitters. I believe this is one of the very first NX300s which was installed in Turkey.
That's in Mersin in southern Turkey.
Okay.
Absolutely.
And it's been on the air for how many years now?
6 years, I believe.
Yeah. Yeah, but quite a lot of those across the country. That's another Turkish installation, isn't it? Do you recall?
Yes, it is. Antalya.
Okay. And here's another.
That's Brookman's Park in the UK.
Yeah. This is in Taiwan, I believe. Republic of China. And that one is a pride and joy of you, Wendell.
That is a 500 kilowatt in a site called Badia in Oman.
Very impressive transmitter. And the customers are very happy too.
Yeah.
And our crowning glory is the largest digital radio deployment of recent memory, 27 transmitters totaling 22 megawatts, I believe, across India. You can see the 100 kilowatt, 200 kilowatt, and 300 kilowatt transmitters across India. And we're what, a little bit more than halfway through supplying those transmitters at this point. So the deliveries are underway, transmitters are being shipped, FATs are being signed off, and it's a very exciting process for Nautel. And all these transmitters are equipped with DRM, and they intend to make good use of it. We're very excited about that. So to summarize, the NX series is the most advanced medium wave transmitter series available today. It's available from 25 kilowatts to 2 megawatts with unparalleled efficiency. Nobody touches it. It's ready for all forms of digital radios, complete with powerful test equipment that you don't pay extra for. It's built in, and it's equipped with probably the most valuable thing of all, and that's our continuous improvement program, where we continue to supply and upgrade technology that has been long since shipped to a customer. So now we get to see what questions people have asked, and so we're going to get to the questions. So some people have mentioned that it's a little hard to hear. Oops. Let me go back to that again. It's a little hard to hear, Wendell. I apologize for that. Understood. We've been trying to bring that level up. And let's see here. And the next question is from a gentleman who asks, will you be making lower power AM transmitters with the AUI? That's a question we get all the time, and I would recommend that you stay tuned. There's a lot of work going on those areas at this point in time. The question about where is the signal that is subjected to MER measurement obtained from? That's obtained from those output sampling probes, both voltage and current, at the output of the transmitter, I believe, and it's actually a directional coupler. So it is the most accurate that you can have that measurement. A gentleman from Philadelphia with an NX50 installed back in 2010, and he talks about the temperature in the controller, and he wants to know about whether or not it should be that way, and he wants to talk to, I would suggest that you talk to the customer service department about that. I don't think we typically have issues with over temperature in the controller. Yours is in the yellow range. I would talk to the customer service team about that and make sure that everything is good on that. Is it possible to do an MER analysis on a receive signal, i.e. from a receive antenna? No, I don't believe that's possible at this point in time. It has to be coming actually off the transmitter. Something we continue to consider as well is the possibility of making some of the test equipment that we have available to other transmitters, but it's not something we've gotten into the development yet. And the gentleman is saying, he says, we have our own stream on the internet. Will the AUI pick up that stream, or will I need a computer at the transmitter site feeding the transmitter? No, it's exactly designed to do exactly that. The purpose of the streaming, the ability to put a stream on the air, that is shoutcast or icecast, is in case your STL should fail. Many stations have an online presence, our webcasting as well. And what this transmitter can do is when it sees the silence, it can be programmed to go down onto the web to the web address that you specified, as long as it's shoutcast or icecast, bring it in and put it on air automatically. And that's exactly the purpose. These transmitters try to stay on the air. And let's see what else we got here in terms of other mentions. And still looking for all these questions. A lot of questions today. It's great. And then another customer would like a lower powered AM NX series. He's looking for a 5 kilowatt. And like I said, watch this channel. This gentleman is looking for an NX400 with an Burke ARC Plus site controller. Are there any plans to work with Burke to produce a Plus Connect option for the NX series? I believe we have talked with Burke about integrating some models with the AUI. Probably would not be additional difficulty, or because now we have SNMP traps, it should be possible to tie in via SNMP as well. How is the efficiency of the ND and XR different than the NX series? Wendell, you'd probably best to answer that. Do you remember the efficiency of the old ND series?
72%.
72%. We're talking now 88 or 80 or 90% in the NX. So that's a substantial difference. 3 times more heat or so is being generated. Can you elaborate on the feature that plays from a USB stick? Is that part of the single board or computer, or does it provide or require an outboard player of some sort? It's all built right into the single board computer. Now, I should mention that if you've got an existing transmitter or a new transmitter and you want this streaming functions, there's actually a cable that's necessary that's got to go in. It's a USB audio device that outputs AES EBU and then goes in and plugs into the controller. But it's a relatively simple installation, plug and play as it were. Is it possible to see RF output in amperes? Good question. I haven't seen that one before. No, I don't believe today that it is possible to see RF output amperes. Could be calculated, but it's not something. I like that point. That's from a station in Toronto. Thank you for that thought. Well, I think that'll be something we'll take a look at. How can we control the efficiency of the transmitter? That's a good question. I'm trying to understand what you mean control. It's you can test it. You can use a clamp type ammeter and a voltmeter to determine the AC in to RF out efficiency and calculate it that way. Really, that's the way it should be done. And given the tolerance of virtually any kind of watt meter, you're going to want a calibrated calorimeter or something like that, or something that's traceable to that in order to show it. But we generally do that during an FAT, and we always pass the 90%. And that's the question. So I think we've exhausted all issues, and we appreciate very much everybody being here with us today. So for Wendell Lonergan, I'm Chuck Kelly, thanking you all for being here.
Thank you.